The same thing happens with the ammonium hydroxide. If we take two hydrogens off and an oxygen off, we get ammonia. When we take a water molecule out of this, we get CO2. That's how I remember what gaseous product these form. It's just taking a water molecule out. So when we write equations for gas evolution reactions, we're going to write a skeletal equation, and we're going to look at the reactants and the products that form. How do we predict the products? We just do that double replacement. We swap partners. But then if we see one of these guys, H2CO3, H2SO3, NH4OH, if we see one of those, we need to say, oh, wait a minute, we're not done. That's going to decompose into a gas. And so we have to just remember to do that and then balance the equation. Let's do an example. Write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. Hydrobromic acid. What's the formula for that? HBr. Hydro tells us it's not an oxyacid. That's hydrogen and bromide. So that's HBr. That's going to be aqueous. Potassium sulfite. So potassium is K+. Sulfite is the light version of sulfate. SO3, 2-. So potassium sulfite is K2SO3. And that's aqueous. And then we have to predict the products. We're going to do that by swapping partners. Learning the swapping partner thing is really important. So we'll end up with H+ and SO3, 2-, and we'll have K+ and Br-. So then we write these as their formulas. We got +1, -2. This is going to end up being H2SO3 and KBr. That's soluble. When we see this guy, ding, 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 should go off in your head, and you just say, oh, that one's not stable. That's going to decompose. So the H2SO3 is going to come apart into water, which will be a liquid, SO2, which is a gas, and then we still have the KBr. So the ionic compounds switch partners. It forms sulfurous acid, but sulfurous acid is not stable, and it will decompose into water and sulfur dioxide gas. Any questions? Is that balanced? We should probably balance it, huh? There's 2 potassiums on the left side. So I need a 2 in here to get the 2 potassiums. Now if I look at the bromides, I've got 2 bromides on the right. I need 2 bromides over here. And now I've got a total of 2 hydrogens on the left, 2 hydrogens on the right, 3 oxygens on the left, 3 oxygens on the right, 1 sulfur on each side. So that's the balanced equation. Any questions?
Why did you add the water?
Why do I add the water? Well, what we really have going on here is our first product was H2SO3. And that just falls apart. It's not very stable, and it falls apart into water and sulfur dioxide gas. So this water came from here. So it's just that molecule came apart. It's a very good question. Anybody else?